pitch, and dr is the root diameter or minor diameter, root dia of the thread, and F is the load acting. This is the transverse shear stress. Now then we have the shear stress due to torsion. Due to torsion of the shaft, tau will be given by 16T by pi d cube. This is mainly happening due to the twisting of the shafts. This is another kind of stress which comes in the power screws. Then we have the bearing stress, bearing or contact stress. Which is given by F by pi dm n p by 2. The contact stress will be the area in contact, that is this area, that is this will be pi dm into p by 2, pi dm into p by 2 will be the area. So n threads will be in contact, so it will be pi dm by 2 into n. This will be the bearing stress. So these are the different types of stress which comes in the power screw. So when we go for designing of a power screw, we can see these stresses and find the resultant stress by means of the principal stress theory. Now we will see about eccentrically loaded bolted joints in shear. Now when we have a series of bolts, for example 5 bolts are there, each of area A1, A2, A3, A4, A5 at different distances, if this is x axis and y axis, then the first thing which we have to do is find out the centroid of the bolts. Now centroid location, if C is the centroid of the combination of bolts, then the x coordinate of the centroid can be given as A1 x1 plus A2 x2 plus 3x3 plus A4 x4 plus A5 x5 divided by A1 plus A2 plus A3 plus A4 plus A5, or this can be written in other ways as sigma AI xi divided by sigma A. This is a x bar. This is a centroid location of the series of bolt systems. Similarly, the y coordinate of the centroid is given as A1 y1 plus A2 y2 plus A3 y3 plus A4 y4 plus A5 y5 divided by A1 plus A2 plus A3 plus A4 plus A5 can be written as sigma AI yi divided by sigma A. Now this is the x coordinate and y coordinate of the centroid for the system of bolts shown in this figure. Now we will come to a case of eccentrically loaded bolted joint. Now eccentrically loaded bolted joints in shear. This is the case which is shown here. This is a cantilever in which a load P is acting at a distance E from the centroid, and this is fastened to another rigid wall by means of 4 bolts 1, 2, 3 and 4. So this point is the centroid of these 4 bolts and the force is acting here. So what kind of shear force gets generated in each bolt? So in order to design this bolted joint, we should know what is a kind of shear force which is coming in this bolts. Now how do we do this? Now the load P is acting at a distance of E from the centroid or centroid of this joint. So how do we go ahead? What we do is we translate the force from this point to the centroid as shown here. When the force is transferred from one point to another point, it is accompanied by a moment or couple given by the force into the distance between the 2 points. So this is the principle of translation of force. Sorry. Now the first step is translating the force from this point to the centroid. So I will say the first step is to find the centroid of the bolt location. System of bolts. System of bolted joints. That will be the first step. And the second step would be shift the force from end to the centroid location. In that case, the force is accompanied by a couple. Given by force into distance. Now next, what we will be doing? So next is, now when the force and couple is acting at this point, what will be the kind of shear force generated in these bolts? Now what we do is, this bolted joints we take separately. These are the 4 bolts, 1, 2, 3 and 4, and this is the force P and this is the moment PE acting at the centroid of the bolt systems. Now when this force and a moment is acting at this point, this force P causes a primary shear force at all the bolted joints. This imaginary force P at the centroid results in primary shear force, basically P1 dash, P2 dash, P3 dash and P4 dash. So these are the primary shear. The primary shear force will be generated due to the load that is given by P1 dash, P2 dash, P3 dash and P4 dash. And since all the bolts are equidistant from the center and it is symmetric about the centroid, we can say that P1 dash equals P2 dash equals P3 dash equals P4 dash equals P by 4, because there are 4 number of bolts. So thus we can solve for the primary shear force. So this will be the third step. Third step will be to find the primary shear force. Now then the fourth step comes the secondary shear force, which is generated because of the couple PE acting at the centroid. This couple about the centroid results in the secondary shear force, basically P1 double dash, P2 double dash, P3 double dash and P4 double dash. Here in this figure, this green values are the primary shear force and this color shows the secondary shear force. And the secondary shear force will be acting in such a way that it will be normal to the line connecting the bolt to the centroid. And it is assumed that the secondary shear force at any bolt is proportional to its distance from the centroid. Suppose if we assume that these distances are given by, like, let the bolts be at a distance of R1, R2, R3 and R4 from the centroid. In that case, we can say that the secondary shear force P1 double dash is proportional to R1, P2 double dash is proportional to R2, P3 double dash is proportional to R3 and P4 double dash is proportional to R4. Or we can write P1 is equal to C times R1, P2 is equal to C times R2, P3 is equal to C times R3 and P4 is equal to C times R4. And what we can say about the moment equilibrium of this system of bolts? We can say the net moment acting at the center PE is equal to P1 double dash into R1, that is P1 double dash is a secondary shear force. This multiplied by the distance from the centroid will give the moment due to this secondary shear force at the center. Similarly, due to other secondary shear forces, we have P2 double dash into R2 plus P3 double dash into R3 plus P4 double dash into R4. This will be the total moment. Now, substituting this relation, the relation of P1, P2, P3, P4 in terms of C R1, R2, R3, R4, we can write this is equal to C R1 square plus C R2 square plus C R3 square plus C R4 square. Here in this case, we have in the previous system of bolts, we can assume that R1 is equal to R2 is equal to R3 is equal to R4. Otherwise, we will go ahead with the same thing. So, we get C is equal to PE divided by R1 square plus R2 square plus R3 square plus R4 square. So, what will be P1 double dash? P1 double dash we know is equal to C1 into R1, C into R1, that is equal to PE R1 divided by R1 square plus R2 square plus R3 square plus R4 square. Similarly, we can get P2 double dash, P3 double dash and P4 double dash. Now, once we get the values of this secondary shear force, now we have two shear forces which are acting at an angle. So, we have to find what is the resultant shear force acting at each location. Therefore, at each location I have shown that is the primary shear force and the secondary shear force is shown in each of the bolt location. And if two concurrent coplanar forces are acting at a point, then we can find the resultant by means of parallelogram law. So, we can draw a parallelogram and find the resultant force. Similarly, we can find the resultant force here also. So, I can write that the resultant force here, I can write it as P1. Here the resultant force will be P2. Here the resultant force will be P4. And here the resultant force will be P3. Thus, at each location I can find what is the resultant force P1, P2, P3, P4 are the resultant shear force. Obtained by vector addition. Vector addition of primary and secondary shear force. Thus, you can find the resultant shear force at any other bolt location. And from this diagram itself, it is very clear that the resultant is maximum at bolt 2 and bolt 4. So, this resultant is maximum. So, these two bolts will be subject to the maximum shear force. So, once we descend these two bolts to take the load, the other two bolts also get automatically will take the load. So, thus we can do the bolted joint design for the bolted joints which are subject to eccentric shear loading. Now, we have a question here. A steel bar of 10 by 50 mm is cantilevered with two M12 bolts P and Q to support a static load of 4 kilonewtons shown in the figure. Now, the primary and secondary shear load on bolt P, that is a question. Primary and secondary shear force on P. So, what will be this? What will be the primary shear force? Now, the primary shear force, now we have the two bolts P and Q. Now, we will transform the force from the end to this point. So, we have the 4 kilonewtons acting at this point along with a couple of value. What will be the value of the couple? M is equal to P into E, that is equal to 4 kilonewtons into what is the distance? This is 400 So distance from here to the centroid will be 1.7 meters plus 0.1 plus 0.2. So the distance to the centroid will be 2 meters. So moment will be 2 into 4000, that will be 8000 Newton meter. So 8000 Newton meter will be the moment acting at this point. So what will be the primary shear force on each of the bolts? Primary shear force P1 dash is equal to P2 dash is equal to P by number of bolt is 2. Number of bolt is 2, therefore it will be 4000 by 2 is equal to 2000 newtons. 2 kilonewtons is the primary shear force on bolt P and Q. What about the secondary shear force? We know that P into E is equal to P1 double dash R1 plus P2 double dash R2, and we also have found out that P1 double dash is equal to PE R1 by R1 square plus R2 square. So what will be R1 and R2 here? R1 is the distance of bolt 1 from the centroid. So what is that distance? Here in this case we can say R1 will be equal to R2 is equal to 200 mm or 0.2 meters. So what is P1 double dash? It's equal to P into E. P is 4000 into E is 2 meters into R1 is 0.2 divided by R1 is 0.2 square and R2 is 0.2 square. So what will be this? Be 1600 divided by 0.08. This will be 20 kilonewtons. It will be 20 kilonewtons. Therefore, the primary shear force on bolt P is 2 kilonewtons, and the secondary shear force on the bolt P is 20 kilonewtons. Now, what is the resultant shear stress on bolt P? On bolt P. Now, what will be the resultant shear force? Now, if you take the bolt P alone, we know that what will be the action of the primary shear force? Primary shear force will be acting like this, P1 dash, and secondary shear force? Secondary shear force will be acting in which way? Okay, so we'll draw the bolt P here. If this is the bolt P, the primary shear force will be acting against the load of 4 kilonewtons. So direction will be upward. And what will be the direction of the secondary shear force? This moment is coming clockwise. So therefore the secondary shear force will be acting in such a way that the moment caused by that will be in the anti-clockwise direction. So it will be this way, P1 double dash. So what will be the resultant shear force? Resultant shear force is equal to 20,000 minus 2,000, that is equal to 18,000 newtons or 18 kilonewtons. So what is the shear force acting, shear stress on it? Shear stress will be equal to shear force by area of the bolt, that's equal to 18,000 divided by pi into, it is told it is M12 bolts, so we can take it as 0.012 square by 4. What will be this equal to? So this will come out to be 159.15 MPa. So the resultant shear stress acting on bolt P is 15.19 MPa. So what about the resultant shear stress in the bolt Q? Resultant in Q is equal to, that will be 20,000 plus 2,000, because if you take bolt Q, P2 dash will be acting in this way And what will be the action of P2 double dash? Since it is this way, P2 double dash will be acting upwards. P2 double dash will also be acting in the upward direction. Therefore, resultant is equal to P2 dash plus P2 double dash. So that is equal to 22,000 newtons. Therefore, shear stress is equal to F by A is equal to 22,000 divided by pi into 0.012 square by 4. What is that equal to? 22,000 into 4 divided by pi into 0.012 square. That will come out to be 194.5 MPa. So 194.5 MPa is the maximum shear stress coming in bolt Q, and 159 MPa is the maximum shear stress coming in bolt P. So this is a question from GATE 2008. So this kind of questions can be easily solved using this principle of eccentric loading on bolted joints. So this way we can easily find out the resultant shear stress in the bolted joints and do the design of the bolted joints accordingly. So in the next part we will see about the weld joints. Yeah, before winding up on this bolted joints, eccentric load on bolted joints, to make sure of the concepts, we will try to solve one more problem. Here again a cantilever beam is loaded with 5 kilonewtons. A plate is subjected to a force of 5 kilonewtons and fixed to a channel by means of 3 identical bolts shown in the figure. The bolts are made from plain carbon steel whose yield strength in tension is given as 380 Newton per mm square, and the factor of safety is 3. Now what will be the size of the bolt? Now how do we solve this problem? So to start with, what will be the primary shear force? What will be the primary shear force? Primary shear force P1 dash will be equal to P2 dash equal P3 dash. So we will mark this as 1, this as 2 and this as 3. So P1 dash is equal to P2 dash is equal to P3 dash is equal to P by 3. That will be equal to 5000 divided by 3. And what will be P2 dash? We know that P2 dash is equal to PE R2 divided by R1 square plus R2 square plus R3 square. Or we will say P1 dash, P1 double dash is equal to PE into R1 into. So here R1 is equal to 75, R2 is equal to 0 and R3 is equal to 75. So what will be this? It will be, what is P is 5000. What is E? E is equal to the distance from this point to this point. This is, we are shifting this force to the centroid. So the moment will be 5 into this distance, 75 plus 230, that will be 75 plus 230, that is equal to 305 mm. So we have 5000 into 305 5 into R1 is 75 divided by R1 square 75 square plus 0 plus 75 square. This will be 5000 into 305 into 75 square divided 75 divided by 2 into 75 square. This will be 10166.67 newtons. This will be my secondary shear force, and primary shear force is 5000 by 3, that is 1666.67 newtons. This is my primary shear force and this is my secondary shear force. So which of the bolts will have the maximum shear stress? Suppose if you take bolt 1, in this bolt 1 we can say Okay, we'll say take bolt 1, 2 and 3. Now we have the force acting this way and the moment acting this way. Force is 5000. The moment is 5000 into 305. 5000 into 305, that's equal to 1.1525 Newton meter. Now this will cause a primary shear force of this way in each of them, and secondary shear force will be acting this way. So this will be P1 dash, P2 dash, P3 dash, this will be P1 double dash, this will be P3 double dash. So it is very clear that the third bolt will have the maximum shear stress or the maximum resultant shear force, and resultant shear force in bolt 3 will be given as P3 dash plus P3 double dash. This will be equal to 1666.67 plus 10166.67. This will be equal to 166.67 plus 101.67, 1183.34 newtons. This is the resultant shear force. So what will be the resultant shear stress? Resultant shear stress will be P by A, that will be P by pi d square by 4, that's equal to 4P by pi d square. So what will be this equal to? Be equal to 4 into 11833.34 divided by pi d square. This will be equal to 4 into 11833.34 divided by pi. So it will do 15066.67 by d square. Now we have got, this is the maximum value of shear stress which my bolt can take. Now we have got that the yield strength of the material is given as 380 Newton per mm square. So we know that if yield strength in tension is given as 380 Newton per mm square, the yield strength in shear will be given as 0.577 times the yield strength in tension. This will be 0.57 into 380. This will be 380, 219.26. So my shear stress will be equal to the yield strength in shear divided by factor of safety. So this will give us 15,066.67 by d square equal to 209.26 Newton per mm square divided by factor of safety is 3, which gives d square is equal to 15,066.67 into 3 divided by 219.26, 206.14. And d will be almost equal to 15 mm. So in this case, the worst case we can go for more than M15, like M18 or M20 bolts can be used for this application. This way we can find that you can do the design of bolted joints which are subjected to shear load due to the eccentric loading. So with this we finish the bolted joints. Next we will go to the welded joints.